In this lesson, we are going to cover solving systems of linear equations in just two variables. This is covered in section 4.3 of your book. There are three ways that you can solve systems of linear equations. The first way is by graphing. Then the addition, otherwise known as the elimination method, and substitution. All right, so we're going to focus on these second two methods. In graphing, we're not going to cover that in this lesson, but all you do is just graph your two equations and then find where they intersect, and that'll be your answer. But we're going to work on solving using these two methods right here. So when you're solving systems of linear equations, you're solving for an x value and a y value. We've worked with these two variables before. This is called an ordered pair and can be written in the form of x, y. So the addition and elimination method. We call this method the addition method because you will be adding your equations together. We also call this method the elimination method because something is going to eliminate from your problem when you solve. Okay? So got a couple of steps here. So really you're going to work with these first two steps at the same time. Step one, ensure that one of your variables will eliminate when adding them together. And then step two is to add your two equations together. So before I add them together, I need to make sure, okay, is one of them going to cross out? So in order for a variable to eliminate, one of them has to be positive, one of them has to be negative, and they have to have the same coefficient, which means the number in front of the variable. So if you notice here, if I had these y's and I were to add them together, they would cancel out because that's like a positive 1 minus 1 would give you 0. So that's why those cancel. So since they'll cancel, we can go ahead and solve. So we add these two equations together. So x plus 3x is 4x because there's an understood 1 here. And then 5 plus 7 is 12. To get the x by itself, you divide both sides by 4 to get x equals 3. So our answer is going to be an ordered pair form, and we're going to put the 3 in place of where the x should be. Remember, it's x, y. So now we have to find our y value. So that brings us to step number 4. Plug your answer for that variable into one of your original equations to find the remaining variable. So we're going to choose either the top or bottom equation, it doesn't matter, and we're going to plug in that 3. So if I were to choose the top equation, the first thing I'm going to do is just go ahead and rewrite it originally, and then I'm going to plug in that 3 for my x. Now remember, when you plug in a number for a variable, you need to use parentheses. It can get a little tricky in some more complex problems, so that's why we want to do that. So I'm going to subtract 3 from both sides to solve, which gives me y equals 2. Now if you chose the other equation, that would have been fine as well. So plug this 3 in for your x. And so I would do 3 times 3, which is 9, minus y equals 7. Subtract 9 from both sides to get negative y equals negative 2. And then to get that y to be a positive, you would divide it by a negative 1, which would give you y equals 2. So it doesn't matter which which equation you plug that into, you should still get the same answer. So that's a kind of a good way of checking yourself. So for the remainder of this video, I'm only going to plug it into one of the equations. So now when we look at number 2, we're saying, okay, is one of our variables going to eliminate? If you look, you will have the x's eliminate. It's positive 2 minus 2, that would give you 0. So y plus 5y is 6y. And then 3 plus negative 9 is negative 6. Now we're going to divide 6 by both sides to get that y by itself. So y equals negative 1. Now be careful, make sure you plug that into the y value. So it's my y, so it's going to go in that second value. So now we're going to plug that into one of our equations. Just by looking at this, I think the top one is going to be the easier one to plug it into. So I'm going to rewrite it as 2x plus y equals 3. And then I'm going to plug that negative 1 in for my y. So to get that negative 1 to go to the other side, I'm going to add 1 to both sides, which gives me 2x equals 4. And then divide both sides by 2 to get x equals 2. And so that's your answer. So you are, you have an answer of 2 and negative 1 for number 2, and 3 and 2 for number 1. All right, and I apologize about the quality of this paper, y'all. I really do apologize. So now, if we look at number 3, notice your y's are going to cancel. So let's go ahead and add these together. 5x equals negative 25. Divide both sides by 5 to get x equals negative 5. So make sure you plug that into the x value. And now I'm going to plug that into one of my other equations. So I think the bottom one would be easier this time. So you rewrite the original problem and then plug that negative 5 in for your x. Sorry about that, y'all. That's a 5y. All right. So multiply here. So negative 15 plus 5y equals 0. Add 15 to both sides to get 5y equals 15. And then we're going to divide both sides by 5 to get y equals 3. All right. So now when we look at number 4, we'll notice that those x's are going to cancel. So negative y plus 3y is 2y. Negative 6 plus 18 is 12. To get the y by itself, you divide both sides by 2. So our y is 6. And then we're going to plug it into one of our other equations. To keep everything positive, I'm really going to just want to stick with the bottom one. So 4x plus 3y equals 18. Plug the 6 in for the y value. So don't get tricked. Plug it into whatever one you found first. So like here we found the x first. So we plugged that into the x of the other equation. This one we found y first. We plug it into the y of the other equation. So it does matter, so be very careful there. So now to solve, I'm going to multiply here, which gives me 4x plus 18 equals 18. Minus 18 on both sides to get 4x equals 0. And then divide both sides by 4 to get x equals 0. All right, so my answer for 3 is negative 5, 3. And then for 4, it's 0, 6. All right. So when we look at number 5, we're going to notice that none of my variables are going to cancel out. If I had these together, that would give me a 4x. And if I had these together, that would give me a 2y. So none of them are going to cancel. So in order to make your variables eliminate, you need two things. You need the same variable with the same coefficients. And that just means the number in front of the variable. And then you need the same variable with opposite signs. So that just means one of them has to be a positive and one of them has to be a negative. So when we're looking here, we're going to see if they satisfy any one of those criteria. So do either of them have the same coefficient? Well, the y's do. Are any of them opposite signs? No, they're both positive here and both positive here. So since my y's have the same coefficient, those are the ones I'm going to want to work with. So I'm going to need to make one of those a negative, but I can't just change it. If I do something to one term, I got to do it to all of them. So I can multiply the top by a -1 or the bottom by a -1. I'm going to do it by the bottom because if I do, that would make this x here a negative, which would make my x's when I add them together a positives because I have more of the positive up here. So I'm going to multiply this here by a -1. So this guy isn't going to change, so I'm just going to rewrite him over here. And this, I'm going to distribute that -1 to each one of those terms. So that's -x minus y equals -3. So now I can add these two equations together like we did on the previous page. 2x equals 10. To get my x by itself, I'm going to divide both sides by 2 to get x equals 5. So now I'm going to plug my 5 into one of my equations. So it doesn't really matter which one, but I'm going to choose the bottom one because it seems to be the easiest. So 5 was my x, so I'm going to plug in a 5 here. And then I would minus 5 on both sides to get the y by itself. So x was 5, -2 was y. All right, so now let's look at number 6. Well, none of them have opposite signs, but you notice that the y's have the same number in front, so those are the ones I'm going to want to use. I'm going to want to eliminate those, so I would multiply this bottom equation by -1. Again, I chose the bottom equation because that would give me a bigger amount of positive x's. If I had done it up here, that would have made that a -6 plus x, which would have given me a -5. So I want to make the smaller number of x's negative. So this guy isn't going to change, so I'm just going to rewrite him over here. And then this guy, I'm going to distribute that -1 again. So that gives me a -x plus 2y equals 5. So now we add those equations together to get 5x equals 15. And then divide both sides by 5 to get x equals 3. All right, so now I'm going to plug that 3 into one of my equations. Honestly, they all kind of stink to plug them into, but I'm going to choose the bottom one. So x minus 2y equals -5. Plug in a 3 for our x. So -3 on both sides. So -2y equals -8. Divide both sides by -2 to get y equals a +4. All right. So now let's look at number 7. So notice here, none of them have the same coefficient. But you notice that your y's, this one is a negative and this one is a positive, so that's going to be the easiest one to work with. So we're going to want to eliminate the y's. So I'm going to multiply this bottom equation by 2. Because if this one's already a positive, that one's already a negative, all I have to do is make both of these have the same number. And I know if I just multiply them all by 2, that would give me a 2y there. So this top equation doesn't change, so I have 5x minus 2y equals 4. And this bottom equation becomes 6x plus 2y equals 18. So now we add them together. 11x equals 22. X equals 2. So now we plug that into one of our original equations. I think that the bottom one would be the easiest here, but it doesn't matter which one you use. So plug a 2 in for your x. 3 times 2 is 6. And then minus 6 on both sides to get y equals 3. All right. So number 8, this one is a little tricky because none of them have opposite signs. Like both my x's are positive, both my y's are negative, and none of them have the same coefficients. So we're going to have to look and see which one's going to be the easiest to work with. Anytime that you have a variable that has a 1 in front, that's going to probably be the easiest one to work with in this kind of scenario. Because in order to get these two the same, we would have to multiply the top by a 2 and the bottom by a 5. And one of those would have to have been a negative to get them to cancel. But here, if I were to multiply this bottom equation by a -3, then notice that a 3x, and then when I multiply that together, that would give me a -3x. My x's would cancel there. All right, so I get 3x minus 5y equals 13. And then when I distribute that negative 3, I get negative 3x plus 6y equals negative 15. And again, I distributed that negative 3 to get this bottom equation. So now we add both of them, and we're left with y equals negative 2. Because 6 and negative 5 is a positive 1, and then negative 2. So now I plug this into either one of the original equations. I'm going to choose the top equation this time. So 3x minus 5y equals 13. Plug in that negative 2 for my y. And now negative 5 times negative 2 is going to give me a positive 10. Now we minus 10 on both sides to get 3x equals 3. Divide both sides by 3 to get x equals a 1. Okay, number 9. So here we don't have the same coefficient on any of them, but we do notice that one of them is a positive and one of them is a negative on our y's. So we can multiply our top equation this time by a positive 2, which would make my y's both have a 4 in front to get them to cancel. So my top equation is going to be 14x plus 4y equals negative 2. And my bottom equation doesn't change. So now 14x and 3x is going to give me 17x. Those guys are going to cancel, equals 17. Divide both sides by 17 to get x equals 1. Then we're going to plug that 1 into one of our other equations. I'm going to choose the top one this time. All right, so I plugged in my 1 in for my x, so I have 7 plus 2y equals negative 1, minus 7 on both sides to get 2y equals negative 8. Divide both sides by 2 to get y equals a negative 4. Now, y'all, it's definitely possible to get fractions here on these problems. However, I'm trying to keep them all whole numbers. I'm giving you specific problems that make these whole numbers, just because I want us to learn the basics of this in here. So don't just think that if you get a fraction you did it wrong, because it's totally possible to get fractions as these answers. I just specifically picked problems that gave you guys whole numbers. All right, so finally, when we look at number 10, none of them have opposite signs and none of them have the same coefficient. But remember, I gave y'all a little tip that if you have a coefficient of 1, that's going to be the easiest one to change. So I'm going to multiply that guy by a negative 5. That'll make my x's cancel. So this top equation becomes negative 5x minus 10y equals negative 30. And then my bottom equation becomes 5x plus 3y equals 2. Now we're going to add those together to get negative 7y equals negative 28. Divide by negative 7 to get y equals 4. All right, so now plug that back into one of your equations. I personally think the top one would be easier. So x plus 2y equals 6. Plug in that 4 for my y. Oops. This should have been a 2, guys, sorry. So bring the 2 down, plug that 4 in for your y equals 6. X plus 8 equals 6, minus 8 on both sides to get x equals negative 2. All right, so that's how you solve using that addition or elimination method. So now we need to solve using the substitution method. Well, y'all, we call this method the substitution method because we're going to be substituting something. All right, so steps for solving with a substitution method. The very first step is you need to make sure you have one variable by itself. So you either need to have x equals something or y equals something, okay? So on this problem, we do have y equals something. So step 2 says to substitute what the variable by itself is equal to into the other equation. That's a whole lot of mumbo jumbo that says to plug in this 2x that is equal to the y into the y of the other equation. So when I do this, I get x plus, instead of that y, I'm going to put 2x equals 12. And now, to go ahead and solve this, you would just combine your like terms. So you get 3x equals 12. Divide both sides by 3 to get x equals 4. So then it tells us on step 4 to plug your solution for the first variable into, one of the original equations. Okay, so hint, the equation that had the variable by itself will always be the easiest one to plug into. Okay, so that's saying that whatever we get for this first variable, take it and plug it into one of these two equations. It doesn't matter which one you choose, but the one that the variable was by itself on is going to be the easiest. So y equals 2x. Plug in 4 for your x, because that was what we found. So y equals 8. All right, problem 2. We do have a variable already by itself, so that's good. So we take this 2x minus 5 and we replace it with where that y is. Y'all, it's very important that you plug these in using parentheses. So I have 4x minus, and in place of y, I'm going to put 2x minus 5 equals 7. So we have to remove this from the parentheses first. Guys, you can't combine those two terms, but there is a -1 that's being multiplied in front. So you do have to distribute here. So you end up with 4x minus 2x plus 5 equals 7. That's by distributing that -1. So now combine your like terms to get 2x plus 5 equals 7, minus 5 on both sides to get 2x equals 2, and then divide both sides by 2 to get x equals 1. So now we plug that 1 back into one of our two equations, but remember we said that the one that had y equals or x equals was going to be the easiest. So if y equals 2x minus 5, so I'm going to plug in a 1 for my x. 2 times 1 is 2. 2 minus 5 is -3. Okay. So now when we look at this next problem, we notice that none of the variables are by themselves. Okay, so there's not an x equals or a y equals. So in order to use the substitution method, you have to have one variable by itself. So you will want to choose the variable that is positive and does not have a number in front. All right, so when we look through here, because we have to get either an x equals or a y equals, so that's what our whole purpose in this is. So we're looking for the one that's positive, so these y's are out because they're both negative, and the one that does not have a number in front. So that means that we're going to want to get that guy by himself. So if I had x minus y equals 2, in order to get that x by itself, you would add y to both sides, which would give you x equals y plus 2. And I just put this in the descending order because your variables always come before your constants. But if you put 2 plus y, it wouldn't really change anything. So I'm going to rewrite this as x equals y plus 2. And I'm going to just rewrite this one. It didn't change, but it just helps me to see them vertically. So now I'm going to plug in my y plus 2 in place of the x of my other equation. And I'm going to solve it the way I did the other problems. So 4 and then parentheses y plus 2 minus 3y equals 11. So distribute to get 4y plus 8 minus 3y equals 11. Combine your like terms to get y plus 8 equals 11. And then minus 8 on both sides to get y equals 3. Make sure you plug it into your y part. So then we're going to plug this into one of our equations. Remember, the one that was x equals or y equals is going to be the easiest one. So my y was 3. So I have x equals 5. All right, so final problem. So we need to find which equation we're going to get either x or y by itself. So looking for the positive one. So we couldn't use this top x because it's negative. And we're looking for the one that's got just a 1 in front, so nothing else. So it would be this x on bottom. All right, so if I had x plus 2y equals 7, and I wanted to get that x by itself, I would minus 2y on both sides to get x equals negative 2y plus 7. So again, just putting my variable term in front of my constant. All right, so I'm going to rewrite this top equation to be negative 2x plus 3y equals 14. And then this bottom equation is going to become x equals negative 2y plus 7. And I have that because that was what we got up here. So now we plug in this negative 2y plus 7 in place of the x in this top equation. So I end up with negative 2 times negative 2y plus 7 plus 3y equals 14. Distribute here to get 4y minus 14 plus 3y equals 14. Combine your like terms to get 7y minus 14 equals 14. Add 14 to both sides to get 7y equals 28. Divide both sides by 7 to get y equals 4. So now, plug it back into one of your equations. I said that the one that's x equals or y equals would be the easiest. So I'm going to plug in my 4 for my y in this equation. So negative 8 plus 7, so x equals negative 1. All right, so I really hope that this lesson has been beneficial to you, and I wish you the best of luck.